Hello viewers, today we'll talk about batch processing and stream processing. We'll see what is batch processing, what is stream processing. We'll see the difference between batch processing and stream processing. So let's get started. So typically batch processing is used for if you need to do a bulk operation, then batch processing you can use, and if you need to do something in live, then for real-time events you can use the stream processing, as you can see in this diagram above as well. So batch processing processes a huge data volume within a specific time after production. Batch processing compiles a large volume of data all at once. Batch processing processes data size if it is in finite state and specified. In batch processing, input graph in batch processing is static. Whereas if we'll see what is stream processing, then stream processing processes continuous data in real time as it is produced. In stream processing, it is done in intervals as soon as the data is produced. Stream processing data size is unknown and infinite. In stream processing, the input graph is dynamic. Batch processing is done on a large data batch and the latency can be in minutes, days or hours. It requires the most storage and processing resource to process big data batches. The latency of real-time data processing is in milliseconds and seconds, and it processes the current data packet or several of them. It requires less storage for processing recent or current data pocket sets and has fewer computational requirements. Streaming data analyzes continuous data streams and the latency is guaranteed in milliseconds. It requires current data packets processing, hence the processing resource must be alert to meet guarantees of real-time processing. In batch processing, it processes large volume of data all at once, and it may require dedicated staff to handle issues. In case of stream processing, it analyzes streaming cross-device data in near real time. The data output rate must be just as fast as the data input rate. So batch processing has high latency compared to stream processing, which has low latency. Batch processing uses batch processors and stream processing uses stream processors. Batch processing handles static files and stream processing handles event streams. In batch processing, it processes over all or most of the data, but in stream processing, it processes over data on rolling windows or most recent records. So batch processing handles a large batch of data while stream processing handles individual records or micro batches for few records. In the point of performance, the latency of batch processing will be in minutes to hours, while the latency of stream processing will be in seconds or milliseconds. Batch processing refers to the processing of blocks of data that have already been stored over a period of time. For example, processing transactions that have been performed by a financial firm in a week. The data contains millions of records for a day that can be stored as a file or records. The particular file will undergo processing at the end of the day for various analysis that the firm requires, and it will be a time-taking process. Batch processing is ideal for very large data sets and projects that involve deeper data analysis. The method is not as desirable for projects that involve speed or real-time results. Additionally, many legacy systems only supports batch processing. Now, let's see some of the use cases for batch processing. Batch processing is used in a variety of scenarios from simple data transformation to a more complete ETL pipeline. In the context of big data, batch processing may operate over very large data sets, whereas the computational takes a significant amount of time. It works well in situations where you don't need real-time analytics results or when it is more important to process large volume of data to get detailed insight rather than to get fast analytics result. Batch processing use case is in real-time transfer and results are not where results are not crucial. Large volume of data needs to be processed. Data is accessed in batches as opposed to in streams. So these are the use cases where we can use the batch processing, where we have complex algorithm must have access to the entire batch of data. Now some of the technology choice for batch processing is Azure Synapse Analysis. It is an analytic service that binds enterprise data warehouse and big data analytics. Next is Azure Data Lake Analytics. It is an on-demand analytics job service that is used to simplify big data. Next is HD Insight. It is an open source analytics service in the cloud that consists of open source frameworks such as Hadoop, Apache Spark, and Apache Kafka, and more. Next is Azure Databricks. It allows us to integrate with open source libraries and provides the latest version of Apache Spark. And Azure Distributed Data Engineering Toolkit. It is used for provisioning on-demand Spark on Docker is clustered in Azure. What is stream processing? Stream processing is a big data technology that allows us to process data in real time as they arrive and detect conditions within a small period of time from point of receiving the data. It allows us to feed data into analytics tools such as soon as they get generated and get instant analytics results. Stream processing is ideal for projects that require speed and nimbleness. The method is less relevant for projects with high data volume or deep data analytics. Stream processing is useful for tasks like fraud detection, social media sentiment analysis, log monitoring, analyzing customer behavior, and more. Now, some of the technology choice for stream processing is Azure Stream Analytics. It is a real-time analytics and event processing engine designed to analyze and process high volume of fast streaming data from multiple sources. Next is SD Insight with Storm. Apache Storm is a distributed fault-tolerant open-source computational system which is used to process stream of data in real time with Apache Hadoop, Apache Spark in Azure Databricks, Azure Kafka Streams API, and SD Insight with Spark Streaming. Apache Spark Streaming provides data streaming processing on SD Insight Spark cluster. The batch processing model requires a set of data that is collected over time, while the stream processing model requires data to be fed into an analytics tool, often in microbatches and in real time. The batch processing model handles a large batch of data, while the stream processing model handles individual records or microbatches for few seconds. In batch processing, it processes over all or most of the data, but in stream processing, it processes over data on a rolling window or most recent records. From a performance point of view, the latency of the batch processing model will be in minutes to hours, while the latency of a stream processing model will be in seconds or milliseconds. Batch processing is a lengthy process and it meant for larger quantities of information that are not real-time sensitive, whereas stream processing is fast and is meant for information that is needs immediately. So you can see here in the diagram batch processing versus data streaming, where in the case of data streams, continuous data comes as an input and it gives you a live result, whereas in batch processing bulk of data can be processed together. Batch processing is the processing of transaction in a group or batch. There is no user interaction required once batch processing is running. This differentiates batch processing from transaction processing, which involves processing transactions one by one and requires user intervention. Stream processing is the process of analyzing stream data in real time. Analysts are able to continuously monitor a stream of data to achieve various goals. Stream processing is a low latency way to capture information about events while they are in transit processing the data. A data stream or event stream can include almost any type of information such as social network or web browsing path data, factory production and other process data, stock or financial transaction details, patient data in hospital, machine learning system data, or IoT, Internet of Things, or smart devices data. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.